Good morning. Today we are going to be looking at the measures of population change, and under this lecture you should be able to understand the changes in the total population as well as changes in the composition of the population over time. You should also be able to demonstrate understanding of techniques of measure of changes in the total population and assess the methods to changes in the composition of the population. So we will still be considering our case study of how demographics is applied, and in this regard we'll be focusing on how the measures of population changes can be applied. So we'll go directly to the measures of population change, and the first one which we shall consider is simply the population change over time itself, where if you want to measure the population change between time t and t plus n, then we simply take it to be the difference between the population at the time t plus n and the population at time t. So this is our equation for determining the population change over that n year period. So that's our first population change measure. We can also express it as a percentage. So if we are going to express the percentage population change, again we take it to be the population change over that span of time, and we divide that by the population at time t and express that as a percentage. So if we consider the population change of Nairobi between the 2009 and the 2019 census, then to be able to compute this percentage change, we simply take it to be the ratio of the total population change given by the difference between the population in the year 2019 and 2009 to the population in 2009. So you can see for Nairobi, it is at 40.11%. So there has been a growth in this case in the population in Nairobi by 40.11%. So as it is, it seems like a trivial number or a simple to express number, but from it we can be able to infer quite a lot if we present that information in comparison to what has been the total population change for the entire country. So if you were to do that as expressed in table 1.1, so table 1.1 gives us or depicts for us the population change and percentage change from the year 1999 all the way to 2019. It is actually from 1969 all the way to 2019. And once you study the trend, then you can be able to infer meaningful information from it. So if you compare, if we begin from 1969, we can see that again, the percentage change for Nairobi has always been higher than that of the total population of Kenya. So you can see in all scenarios that has been the case, though the percentage change was higher in the 1990 years. So this means that this can be attributed to different factors. It can be a situation where there is more in-migration in Nairobi compared to the other parts of the country, which is reasonable because people are more likely to move to the city in search of jobs. It can also be a situation where the experience of birth rates in Nairobi is higher compared to other places in the country. So, and as we monitor this particular change in comparison to the total population, we're able to see or to determine which areas in the country require more infrastructure in terms of school, in terms of roads, in terms of water sources, and so on. So if we did this for every county, for instance, you'd be able to compare or to determine the allocation of these types of infrastructure, because you're able to tell which county is growing faster than the other. So that is the population change. So again, once you monitor the population change and compare it with other counties, the entire country as a whole, you can also be able to add more information to make this change be more meaningful. So you may be able to gain data on the different age groups, so that you're able to examine what has been this change across the different age groups. Do we have, is the population increase associated probably with youth members or with older people? So you'd expect, for instance, in Nairobi, that growth to be actually attributed to more people who are moving into the city to look for employment. Again, is it increasing? Is that growth rate attributed to increasing men compared to women? So again, previously we've had historically men have been the sole breadwinners of families. So you may have found that probably in the 1969, 1979 cases, during these earlier years, you may find that probably a higher percentage of this population change was actually attributed to increasing men. And then again, you'd want also to measure, is this increase attributed to people engaging in trade, or is it people involved in manufacturing? So as you segment this population change as a planner, you're able to determine what services are actually required, and you're able to plan or make your decisions based on the current population that is there. So that's how we use the population change. So again, planners can also be able to identify locations within a region where the growth is taking place to determine the best location of new services. Is it occurring within urban areas, or is it occurring within rural areas? Is it occurring within certain regions or districts or counties? Again, all that for planning purposes. So that's population change, simply looking at the difference, which can also be expressed as a percentage. So we also have another measure, which is the population density. And this is taken to be the ratio of the total population to the land area. So again, so if you take that ratio, it simply depicts how many people are contained within a specific size of area, or size of land area. So it will give, it will depict a situation where there is overpopulation within a certain area, or some places are actually sparsely populated, whereas others are actually densely populated. Again, informing the planner of where to allocate resources. So if you compare, for instance, the case of Kenya, for the population between 2009 and 2019 for the various counties. So if you compute the population density in 2019, it gives you an overview of which areas are actually densely populated. So you expect that the higher this ratio is, the higher it means that our total population is more compared to the land area. So if we were to go through this table, so this is the areas in kilometers, this is the population as at 209, as at this is the population density as at 209. So simply taken to be the total population divided by the area. So you'll get that for all the counties. The same is done for the population density in 2019. So you simply take the population to the area. So you realize as long as the boundaries are not changed, then the area will still remain to be the same. But our population is exposed to births, deaths, as well as migration. And therefore, the population is changing from one year to the next. So if you look at the first case of Nairobi County here, the population density was at 4,421 in 2009. As at 2019, it was at 5,686. And this is clearly a situation of where we have experienced a growth of population in the county. And this can be attributed to various factors. You can find that it is because there have been probably more births than deaths in that county, maybe due to improved health facility or healthcare. It can also be attributed to a situation where there are more employment opportunities within this county, and that has resulted into this increase in the population density. Let's see if we have a scenario where the population density has actually reduced. You can see for Tana River, there has only been a marginal increase. So this was at 7, and this is now at 9, which is it's still an increase, but a marginal one. This is a good example. So we have Lamu as at 2009, the population density was at 29. Now, as at 2019, the population density is actually 22. So it's a small reduction, but it is a reduction, which again is attributed to, in this case, a reduction in the population. And for Lamu, often year on, we have had cases of insecurity. So we can attribute this reduction of population density to outmigration of people from Lamu County due to security issues. So that is how we read these demographic statistics. So they're simple measures, and how to compute them is simple, but what is meaningful is the information that we actually draw from them. And we can only draw meaningful information if we compare from one year to the next, if we compare from one region to another, from one region to the entire country, so that we can be able to make meaningful deductions. So again, we have another count. Now, is there another county? So that's an increase, that's an increase. So it seems for Lamu, I don't seem to see any other county where we've had a decrease in the population density, but how we infer the information is actually based on that. Again, if you look at the population density, Nairobi accounts for the highest, and that mainly can actually be attributed to immigration, because you find that Nairobi hosts most of the manufacturing companies, most of the headquarters of most offices, headquarters of government offices, and therefore this number is actually can mainly be attributed to immigration. So we can now look at the components of population growth, and they are broadly categorized into 3. Fertility. So fertility is simply associated with births. So if you have a fertile population, then you expect that you will have a high birth rate. And conversely, if you have a less fertile population, meaning that if you have, let's say, an aged population, if your population is mostly composed of aged people who are probably already in the infertile ages, then your birth rate will also be low. Mortality is associated with death. So again, if your population is exposed to a high death rate, then you expect that population to reduce. The other component is migration, which can be inwards or outwards. So migration results into increase in the population. Outmigration leads to reduction in the population. So we can actually model our population change process between time t and time t plus n to be the population at time t plus the number of births between time t and t plus n, and that will reduce by the number of deaths between time t and time t plus n, plus any net migration. So when we speak of net migration, we are referring to the difference between in-migration and out-migration for the specific interval, which is time t to time t plus n. So this is how we can actually model our population based on the three components. So fertility corresponding to births, mortality corresponding to deaths, and migration corresponding to the net migration. So to measure the annual population growth rate, we can use the exponential growth rate formula given by our equation here. So this means that if we want to determine the annual growth rate, symbolized by the symbol R here, we simply take it to be the ratio of the logarithm to base 10 of the ratio of the population at time t plus n to the population at time t. And in our denominator, we'll be having n, which denotes the period at which we are considering, times the logarithm to base 10 of the exponent. And we express that as a percentage. So if we were to look at a specific example, so let's again consider the Nairobi County, where the population in 2009 was 3,138,369, and the corresponding population in 2019 was given by this figure, 4,397,073 people. So if you want now to measure what has been the growth rate of the population in Nairobi County between 2009 and 2019, we will simply apply this particular formula. So let's see how it plays out. So we are saying, let me show the numbers so that, so we'll take it to be the logarithm to base 10 of the ratio of population at time t plus n, where t plus n denotes the population at 2019, and our denominator will be the population as at 2009, and to our denominator we had it as n, which in our case is marked by the difference between the years 2019 and 2009, so that's 10 years, times the logarithm of the exponent. So we know the exponent is given by 2.718. So that's the exponent. So this symbolizes simply the exponent, and we express that as a percentage. So in this case, the Nairobi experienced a growth rate of 3.37% between 2009 and 2019. Again, we can also go ahead and determine what do we expect if that is the current prevailing annual growth rate. When can we expect the population to actually double? So in determining we take it to be 70. So 70 is a constant. And if you want our 70 there simply represents the logarithm of 2. So why we're using 2 is simply because we want to determine the doubling time. So it means that if we had a population of P, then we want a point in time where this population will have grown to to 2p, and therefore that's why we use 70. So 70 here marks the logarithm to base e of 2. So 70 we consider in that case to be a constant, simply obtained from the logarithm to base e of 2. And to our denominator, we have that as the annual growth rate expressed as a percentage. So in our work here, we obtained our growth rate to be 3.37. So if you want now to determine from our 2019 census, when do we expect our population to actually double? Then in this case, it will be within the next 20.77 years. So in the next 21 or so years, we expect that the Nairobi County population will actually double. So with such prediction, a planner should be able to determine if our population will be doubling within the next 20 years. What measures do we need to put in place within that span? Do we need to increase our schools, facilities? Do we need to expand our road infrastructure? So all those things can now be guided by these particular estimates. So we are saying that should services, so the use of this information is that should services and infrastructure be increased to meet the demands of new residents, or in particular, should it only be applied to a particular city? Again, should these strategies and plans be developed to make rural areas or urban areas more attractive to potential migrants? So these are the questions that now will be answered by you measuring these particular quantities. So planners are able to answer the following questions. So is the growth due to high birth rates in the region? Again, is migration primarily responsible for the increase or declines in the population? And so by using these measures, they can now narrow down and determine what meaningful decisions, or what decisions can actually should actually be applied. So in our next topic, we'll now focus on different ratios. So you have identified, for instance, in this case, your population will grow by this much, or you have experienced that the birth rate is this particular is 3.37. So you'd want to know what exactly contributed to this particular growth rate. Is it the births themselves, that the births were actually higher in Nairobi as opposed to other areas? Or is it actually that the deaths were lower in other areas? Or is it that there was more in migration? So we have now, in our next lecture, we'll be focusing on vital ratios, where we'll measure ratios with regards to birth rates. We'll measure ratios with regards to death rates, as well as migration rates. So that shall form our next lecture. So we'll still be building up on these measures of population change, but now focusing on particular vital ratios. So after this video, make sure you do the quiz. That is the only thing that will mark your availability or your attendance for this particular lecture. So ensure you attend the questions, and the scope is actually limited to this particular lecture.